Have you ever wondered why space is completely silent? It is a question that fascinates scientists, astronauts, and curious minds all over the world. When we look up at the night sky, we often imagine stars exploding, planets colliding, and cosmic events of unimaginable scale. Yet despite all this motion, energy, and activity, space remains utterly silent. To understand why, we first need to understand what sound really is. Sound is a vibration that travels through a medium, such as air, water, or solid objects. On Earth, sound surrounds us constantly. From the chirping of birds to the roar of engines, from whispers to thunder, we hear it everywhere. Sound travels through molecules, bouncing and vibrating along the way. Without a medium to carry these vibrations, sound simply cannot exist. Space, however, is a near-perfect vacuum, meaning it has almost no particles at all. The air we breathe, which carries sound so easily on Earth, does not exist out there. Imagine shouting in the vast emptiness between Earth and the Moon. No one would hear your words. They would vanish instantly, traveling nowhere, because there is nothing to carry the vibrations. Even the most violent events in the universe, such as supernovas, gamma-ray bursts, or massive asteroid collisions, do not produce sound in the way we hear it. They release enormous energy, light, and radiation, yet remain completely silent. Astronauts experience this silence directly when floating outside their spacecraft. Inside the spaceship, sounds exist: the hum of machinery, radio communications, and even the creaks of the structure. But step outside and all is quiet. Even if a meteor were to strike nearby, it would produce no audible noise unless it physically interacted with the spacecraft. This emptiness, however, is far from lifeless. Space is teeming with electromagnetic waves, cosmic radiation, and light. Scientists have learned to detect these invisible signals and convert them into sounds we can hear. These recordings are sometimes eerie, sometimes melodic, and often both at the same time. They reveal the hidden symphony of the universe, a music that exists beyond human perception. Astronauts often recount their experiences of this silent expanse. One astronaut described floating outside the International Space Station, looking down at Earth, enveloped by a quiet so profound it felt almost tangible. He could hear subtle vibrations through his suit, but outside, the void offered complete silence. Another astronaut shared how even the tiniest movements, like adjusting a glove or shifting a tether, became distinctly noticeable against the backdrop of nothingness. The silence of space has inspired countless works of art, literature, and music. From science fiction movies to documentaries, humans have always been captivated by a quiet universe. It is both calming and terrifying, reminding us of our smallness, fragility, and our place in the cosmos. Despite the silence, space is far from empty or inactive. Stars are born and die, galaxies collide, and cosmic storms rage in regions far beyond our sight. Each event happens in silence, a paradox that challenges our understanding of the universe. Imagine a supernova, a star exploding billions of light years away. On Earth, we might detect the light or the radiation, but there is no sound, no booming noise, just a silent spectacle across the cosmos. This absence of sound gives space a unique character. While Earth is filled with noise, conversations, traffic, animals, wind, and water, the universe remains a serene expanse. It is almost meditative in its stillness, offering a canvas for imagination. Scientists rely on this silence to study the cosmos with extraordinary precision. Electromagnetic waves, radio waves, and cosmic background radiation travel freely through the vacuum, allowing measurements without interference. Humans have always been fascinated by this silent universe. It is reflected in music, movies, literature, and even in scientific experiments where sounds of planets, converted from electromagnetic data, reveal a haunting yet beautiful audio of what we cannot normally hear. The idea of silence in space also raises a deeper philosophical question. How does silence shape our understanding of existence? On Earth, sound is often associated with life. Cities buzz with activity, forests echo with animals, and oceans roar with waves. Silence, by contrast, often feels empty or unsettling. In space, silence is the default state, and life becomes the exception. This contrast forces us to rethink what it means to be alive in a vast and quiet universe. Technology has allowed us to bridge this gap in perception. Using data from space probes and telescopes, scientists translate electromagnetic signals into audible frequencies. When we listen to these recordings, we are not truly hearing space itself, but rather a human-made interpretation of cosmic data. These sounds can resemble whistles, hums, or even deep vibrations, giving us an emotional connection to something otherwise unreachable. This process helps scientists detect solar storms, study planetary atmospheres, and understand distant galaxies. The silence of space is not a limitation, it is an opportunity. It allows light and radiation to travel uninterrupted for billions of years, carrying information about the earliest moments of the universe. Without this vacuum, much of what we know about cosmology would be impossible. Every image of a distant galaxy, every signal from a pulsar, and every measurement of cosmic background radiation depends on the quiet nature of space. In the end, space is silent not because it is empty, but because it operates under different rules than our everyday world. Sound belongs to planets with atmospheres, to places filled with matter and movement. Space belongs to light, energy, and time on an unimaginable scale. The next time you look up at the stars, remember that beyond the beauty you see lies a universe alive with motion, power, and mystery, all unfolding in perfect silence. Another fascinating aspect of space silence is how it affects human psychology. When astronauts spend long periods in orbit, the absence of natural sounds becomes noticeable. There is no wind, no rain, no birds, and no distant city noise. This lack of familiar sound can feel peaceful at first, but over time it can also feel unsettling. Humans evolved on a noisy planet, surrounded by constant auditory signals that help us understand our environment. In space, those signals disappear, forcing the brain to adapt in unusual ways. This is one reason spacecraft interiors are filled with artificial sounds: beeps, hums, alerts, and radio chatter. These sounds are not just functional. They provide comfort and a sense of normalcy. Silence in space also changes how danger is perceived. On Earth, sound often warns us of threats. We hear explosions, crashes, or approaching objects before we see them. In space, there is no such warning. A malfunction, collision, or sudden decompression happens without sound. This makes space travel far more dangerous and psychologically intense. Astronauts rely entirely on instruments, visuals, and training rather than instinct. The silence forces absolute focus and discipline, where even small mistakes can be fatal. Interestingly, space is not completely empty everywhere. Some regions contain thin clouds of gas, plasma, and charged particles. In these environments, waves can travel, but not as sound in the traditional sense. Instead, they move as pressure waves or electromagnetic oscillations. Scientists sometimes refer to these as space waves, and while they are not audible, they carry energy across vast distances. When translated into sound, these waves create deep rumbles, high-pitched whistles, or rhythmic pulses. These audio interpretations help researchers identify black holes, solar flares, and magnetic storms. These sounds allow scientists to understand invisible forces shaping the universe. By analyzing these translated signals, researchers can detect changes in magnetic fields, measure particle density, and observe cosmic events that would otherwise remain hidden. In this way, silence does not limit discovery. Instead, it demands more creative ways of listening. Black holes, often imagined as violent and loud, are perfect examples of silent cosmic monsters. When matter falls into a black hole, it heats up and emits intense radiation before crossing the event horizon. This process releases enormous energy, but again, no sound travels through space. What we hear in documentaries is simply data converted into audio. The real event unfolds in total silence, hidden behind light years of emptiness. The early universe itself was once very different. Shortly after the Big Bang, the universe was dense and filled with hot plasma. During that time, pressure waves did exist, similar to sound waves. Scientists have detected traces of these ancient waves in the cosmic microwave background. In a sense, the universe once had a voice, but as it expanded and cooled, that voice faded into silence. What remains today is a quiet echo of the universe's birth, preserved in radiation rather than sound. This silence plays a crucial role in astronomy. Because sound does not interfere, telescopes can detect incredibly faint signals. Radio telescopes listen to distant galaxies, pulsars, and quasars, picking up whispers from billions of years ago. Optical telescopes capture light that has traveled uninterrupted across space. If sound-filled matter were everywhere, these signals would be distorted or lost. Silence, therefore, is what allows us to see the universe clearly. From a philosophical perspective, the silence of space challenges human ego. We often associate importance with noise and attention. Loud things feel powerful, while quiet things feel insignificant. Yet the universe proves the opposite. The most powerful forces known to science operate silently. Gravity shapes galaxies without making a sound. Dark matter influences cosmic structure invisibly. Time itself moves forward in complete silence. This realization humbles humanity, reminding us that not everything meaningful announces itself loudly. For future space exploration, silence will remain a defining feature. Missions to Mars, deep space probes, and potential interstellar travel will all occur in this quiet environment. Engineers must design systems that function without relying on sound, while astronauts must prepare mentally for isolation and auditory emptiness. As humans venture farther from Earth, silence will become a constant companion. In the end, the silence of space is not empty or meaningless. It is full of information, energy, and mystery. It is the stage on which the universe performs its grandest events, unseen and unheard by human ears. While we may never truly hear space, we can understand it, study it, and imagine it. And perhaps that silence is what makes the universe so awe-inspiring. In a cosmos without sound, every beam of light, every particle of energy, and every moment in time speaks volumes without ever making a noise.